Hello. So in this video we are still looking at this trigonometric equations. We have part A. We need to solve tan squared theta plus 2sec squared equal to twice into 5 minus 3 times theta. Now we have a range here. The angle we are looking for is restricted between 0 and 180 degrees. So let us see. Now we have tan squared, sec squared. I want you to recall from the Pythagorean identities that 1 plus tan squared theta is equal to sec squared theta. So this identity is likely to be useful here. So let us see if I rewrite this 3 tan squared plus twice. Now I'm going to write the equation which is in tan throughout, so I have to get rid of the sec squared. From here sec squared will be equal to 1 plus tan squared. One plus tan squared theta equal to, now we have twice, then this will be 10 minus 6 tan theta. Alright, so from here we are going to put everything on the left hand side so that we form an equation in a tan. So let us see, this is 3 tan theta, tan squared theta plus 2 plus 2 tan squared minus 10 plus 6 tan theta equal to 0. So it is the same expression, on that I'm bringing that part on the right to the left. So the 10 here become a negative, the negative 6 tan theta will become a positive. And now here, don't forget, I replaced the sec squared with this identity here, 1 plus tan squared theta twice, because this is 2 sec squared. Then removing the bracket, this is 2 and this is 2 tan squared theta. So now let us collect like terms. Collecting like terms here, we see tan squared and tan squared giving us 5 tan squared. Then we have a plus 6 tan theta. Then we have a 2 minus 10, which is minus 8, equal to 0. So hope you can now see that we have a quadratic equation where A is 5, B and C is negative 8. So tan theta will be equal to negative B, that is negative 6, plus or minus the square root of B squared, which is 36, then minus 4 times A times C divided by 2 times A. So we have tan theta equal to negative 6 plus or minus. Let us check and see from the calc here. We are going to look for 4 times 5, then times 8, then plus 36, 196, root answer, this is 14. So we shall get 14 divided by 10. So our tan theta is going to be now negative 6 plus 14, that is going to be 12, I think. No, it is not 12, it is 8. Now 8 divided by 10, we get 0.8. We also have tan theta equal to negative 6 minus 14, that is negative 20, divided by 2, that is negative 2. So these are the two values we get for tan theta. So we need to find out the angles in this range. So let us see. Now to find these angles, we know that tan is positive. For this first one, tan is positive, so tan is positive in this quadrant here and in the first quadrant. So for tan theta to be equal to 0.8, we also have tan theta has a negative 2. Okay, let us see what is the tan inverse of negative 0.8. So the tan inverse here of 0.8 is 36.7. So this principal angle here is 36.7. So it is the same angle here, 36.7. So we need to find the angle from 0 to 180. So we have this. Now the next angle will be out of the range, because we shall get 180 plus this. So we are stopping on this first angle here. So we have theta as 36.7 degrees. Okay, now let us see for the case of tan negative 2. So what is theta? Theta is tan inverse of negative 2, and from the calc here, tan inverse of negative 2 is 63.4, negative 63.4. So let us see that we know that theta is positive in the first and in the third, but here we're interested in the negative side, so we need this and that. So we have this angle here and we have this angle here. So we are interested in the region where our angle is negative. So if it is negative, it means that we are going to consider the third and the second quadrant. So we need, remember the range is 180, so we need to move from here up to here. So this one will be out of range, so we avoid it. We are only going to focus on this. So this is going to be 180 minus, remember this gives us negative 63.4, so we shall get 180 minus 63.4, and that gives us 180 minus 63.4. That angle is 116.6 degrees. So for this first equation here, we see that theta has got solutions of 36.7 degrees and 116.6 degrees. Due to the given range, we couldn't move up to this. Remember this angle is 63.4, 63.4. We couldn't move up to this side because we have to stop at 180. So that is one. We go to part B. So now let us look at part B. And this part we need to solve for the values of theta within this range from 0 to 360. Now I want you to see that we have sine squared, then this is 2 sine cos, and now this is cos squared. Now one way of solving this number when you have cos and sine, you can convert it to tan by dividing with the cos, and this time we shall divide with cos squared so that we get sine squared over cos squared theta minus 2 sine theta over cos squared theta minus 3 cos squared theta divided by cos squared theta equal to 0. The reason I'm doing this is that I want to deal with just one trigonometry ratio. So doing this, I will be getting tan squared theta here, then minus 1 cos cancels cos down here, I will remain with just 1 cos down. So this is 2 sine over cos, which is 2 tan, then minus 1 equal to 0. Again, you can see that we have a quadratic equation forming. So this quadratic equation, our A is 1, our B is -2, and our C is -1. So tan theta will be equal to -b, which is 2, plus or minus the square root of b squared, which is 4, minus 4 times A times C, then over 2 times A, which is 2. So tan theta will be equal to 2 plus or minus. Now what are we having here? Let us see. In this case, we have a 3 here. This was a 3. Let us correct this. So this is going to be minus 3 because it was a 3 cos squared. So our C is -3. So for SC, this will be -3 inside. Okay, so now you can see that we have 12 here plus 4, which is 16. So we get a 4 here divided by 2. So our tan theta is going to be 2 plus 4, which is 6. 6 divided by 2, that is 3. And also tan theta will be equal to 2 minus 4, what is -2. -2 divided by 2, you get a -1. So we need to find the values of theta in the range of 0 to 360. So let us start with, at the first part here, let us get tan theta. Tan inverse of 3 we get 71.5. So tan inverse of 3 is 71.5 degrees, 71.6. Let us take 71.6 degrees. So where is tan positive? First and third quadrant. So for tan, it is positive in the 2 quadrants. So we have that. Then we also need to get this angle. So this is 71.6 and this is 71.6. So the first angle is going to be 71.6 degrees. the second angle will be 180, because we need to add this angle from this 180 plus 71.6 degrees. The other angles will be out of the range because we need to move 360, then we add this, and 360 we add this, so we stop on these two for this one here. So, and I think 180 plus 180 plus 71, we get 20, 251.5. 251.56 or 0.6 degrees. That is the angle for that. So let us now see when tan theta is -1. So tan theta to be -1, the tan inverse of -1 is -45. And where tan is negative, we have here and here. So this is where we have 45, and this one is 45. So we need to move from here up to here. This is 300. No, not 300, but 180 minus 45. 180 minus 45, that gives us, so we get 135 degrees. Then another angle is to move all away from this 0, we move up to this line here, so that angle is going to be 360 minus 45, which is 315 degrees. Other angles will be out of the range, so theta will be 71.6 degrees. We also have 135 degrees. We also have 251.6 degrees and 315 degrees. So this is the solution set. Okay, that's how we do such numbers. Hope you are getting it. Now let us see the last part of question 15. So now in this part C of our question 15, we can see that we need to employ compound angle formula for cos and for sine. Now cos of theta plus 35 is the same as cos theta cos 35, then minus sine theta and sine 45 equal to, we shall get sine theta cos 25, then plus sine 45 cos theta. The expansion of these compound or trigonometric ratios for sine and cos is the one I have employed here. Remember, sine, when there is a plus here, we use a negative, and sine we always begin with cos, then sine. Whereas this one is sine cos, only that we interchange the angles. We have theta here, then we have 45 on sine, then we have 25 here, and we have, oh, this is not going to be 45, this is 25 here, so this is 25. When we expand this, we shall get sine theta cos 25, then sine 25 cos theta. Alright, so now if we want to simplify this, I'm saying a cos theta sine theta, so what I'm going to do is to divide it by cos theta so that I create a tan. Now this will be cos 35 minus tan because when you divide this by a cos, we shall get a tan from this sign, so it will be tan theta then sine 45 equal to, now when divided with the cos in this term, we shall get a tan theta then cos 25, and when divided with cos here, we shall get a sine 25. Cos cancels. So now what we are going to do is maybe to collect like terms. We have the tan. Let me bring this sine 25 this side, so I get cos 35 minus sine 25 equal to tan theta. Here we shall have cos 25 plus sine 45. If I'm to take this on right hand side, then I factorize tan out. Already we have a tan theta cos 25, so we shall have it here. So that means that tan theta is going to be cos 35 minus sine 25 divided by cos 25 plus sine 45. Oh, we don't have 45. Sorry about that. So this is 45. So we need to correct this. So we just have 35 and 25. So this is 35. So even here we have 35. So this is 35. Okay, sorry about that. So let us now find this tan theta. Tan theta is equal to what? So from our calculator here, we're gonna have cos 35 plus minus, so minus sine 25, down we have cos 25 plus sine 35, sine, this is sine 35 which gives us 0.27. This is sine 45 degrees. Okay, so now from here we have got our tan. So next is to find the angles which satisfy this condition here. So let us see where tan is positive. That is in the first and the third quadrant. So we have to find theta. So theta is going to be tan inverse of 0.27, and from the calc here, the tan inverse of 0.27 is 15.1. degrees, so we write it here also 15.1. So we have to move from 0 to 360. So the first one is that 15.5, where ls is tan positive, it is here, so that is going to be 15.1 degrees. Then we have 180 plus 15.1 degrees, and that gives us 180 plus 15.1. we get 195.1 degrees. So our solution is 15.1 degrees and 195.1 degrees. That is the solution for this part C. So thank you for watching, hope it is helpful. So this is question 15, trigonometry. Let's meet in another part of trigonometric equation. Thank you for watching. I am teacher Ginger Isaac. Please subscribe to my channel and recommend the channel to your colleagues who are following mathematics. Okay, thank you.